the introduction, and of course I have the unenviable task of trying to re-energize everybody after a nice lunch, networking, making phone calls, and all that other jazz. So anyway, I'm delighted to have the opportunity to have you and talk a little bit about, and I guess maybe I'm a little dyslexic. I think it's really, we're talking about evolution and revolution, and not the other way around. But we're delighted to be here, and I think that this session is really well scheduled in that it begins to inform and sets up nicely the following presentations. The presentation that follows mine is about really designing and deploying these in-building and outdoor networks. There's another presentation about the toolkit, really sort of a decision tree about what do you deploy in order to deliver coverage and capacity inside buildings. So, Jen, thanks for the introduction, and just for some quick background on who Solid is. I have the privilege of leading marketing for Solid. Solid helps keep people stay connected and safe through a portfolio of RF amplifiers, RF radios, and optical transport solutions. Breaking it down a little bit further, some concrete examples. Some of the work that we've done are distributed antenna system solutions, or DAS systems, have been deployed at the Daytona International Speedway, the New York City subway, and even here locally at Parkland Hospital. Our optical transport solutions, we have the privilege of providing the front haul solution for one of the world's first and one of the world's largest Cloud RAN deployments through SK Telecom. So that's who we are. And let me, we don't have the monitor quite going, so there we go again. So let me get dialed in here. You know, if we look back, if you look at the cellular industry, and we had the chance to spend dinner last night with some folks in the industry, and it's been observed that the industry undergoes transformation and changes, generational changes every 10 years or so. And you know, you think back at the original phones, the bag phones. If you had some bag phones in the audience, I did. You know, were about really mobile voice services. The 90s, 2G, were about voice capacity and text services. The 2000s, you know, 3G, really about rudimentary data services. And here we are now with the launch of the iPhone. It's really about capacity. And I would suggest that really the 2010s are really about a decade of densification. It's marrying coverage and capacity, both indoors and outdoors. And I think we're all familiar with the hockey stick charts of predicting 6 times capacity, you know, over the next couple of years. But I think what gets lost in that metric is very fascinating. In certain markets, at certain times, mostly dense urban areas, we observe that the capacity spikes are much greater than 6x. It could be 10x, it could be 15x, which really speaks to where we are, the dilemma that we face, the decade of densification. And to do that, we've got an interesting debate in our industry of what to deploy. We talk about the macro network. Obviously, the DAS industry has been a thriving industry for quite some time. There was a time where you couldn't go to a wireless conference and not have a session or two about small cells. In fact, we were having a briefing this morning with an industry consultant, and I think one of the new frontiers of what exactly does Cloud RAN mean, and I think we'll have some presentations on that over the course of the next 1.5 days. But I think the point is that we keep talking about this toolkit approach, a toolkit approach for densifying the network, and it's going to take a whole lot of stuff. And I would observe that the technologies, the strategies for densifying the network, we're going to need both evolutionary and revolutionary types of technologies to achieve that. And so the wireless industry, thank goodness for the auto industry, because without the auto industry, I don't think the wireless industry could explain stuff. So let me use the auto industry as a way to provide an analogy for what I'm talking about with evolution and revolution. And so if you think back upon the Mini, and I think we probably got the wrong logo. I'm not talking about today's Mini. I'm talking about the 1968 Mini Cooper, which was, in my opinion, an evolutionary car. And what I mean by that is that evolutionary isn't dramatically changing. Usually it's about shrinking down things. And so you look at the contemporary cars that the Mini competed with, and you had rear-wheel drive with the big old axle, front engine, large cars. And what the Mini did from an evolutionary standpoint was turn things around a bit. You had a transversely mounted engine and a front-wheel drive. So what you created was a car that had enormous fuel efficiency. It had plenty of room for its passengers, but it was a small, compact thing. And I'll draw a parallel to evolutionary solutions in a moment. From a revolutionary standpoint, I would observe the Tesla. So the Teslas choose the internal combustion engine for a completely different platform, an all-electric platform. And so I use that as a basis for comparing and contrasting evolutionary and revolutionary technologies. Evolutionary to me is about shrinking things down. Revolutionary is about a completely different approach. And we're seeing that play out in the wireless industry. And so we all talked about the toolkit. And so in our opinion, this is what the toolkit looks like for densifying the network. Evolutionary technologies, DAS and small cells. In effect, going back to what the Mini did, it shrunk things down. What is DAS? DAS is essentially a shrunk down version of a macro network deployed indoors. What's a small cell? A small cell is essentially a remote radio head shrunk down and deployed indoors. In contrast, you've got more revolutionary approaches like Cloud RAN and optical, what I call it, enterprise indoor passive optical LAN. So let me come back to that in a second. Let's spend a little time talking about these evolutionary strategies and technologies. And so I love this image because I think that the industry, and what I appreciate about this event and this audience is that the discussion, the conversation about DAS and small cells and DAS has advanced. A lot of the discussions have been pitting small cells against DAS. In other words, small cells are going to put the DAS guys out of business. And we, with that, hear a lot of claims. Of course, there's the question of what exactly is a small cell, and I think we all pretty much agree that we're never going to quite get on the same page on that one. But we've heard a lot of very interesting presentations about what can and can't be done. Some examples are the claim that DAS is too expensive to compare to small cells, that small cells can be deployed in stadiums, large, high-capacity venues for 1/10 or 1/20th cost of DAS. And so I think the discussion needs to advance into more pragmatic conversation about how do these deployments, how do these solutions, how do they work together, how do they work in harmony, what's the decision tree, and I believe Andy's probably chairing or moderating a panel later today that may wander into that area of what the decision tree is. I think that as a rule of thumb, we would observe that DAS is an ideal, there's a business model behind it, there's an economic story behind DAS being the ideal tool in the kit for large venues. Large venues, let's call them over 500,000 square feet. At the other end of the spectrum, I would observe that small cells are ideal for buildings, let's call them what they are, buildings, under 100,000 square feet. But that leaves this in-between battleground, which to me is really a fascinating story, and one that I think as we continue to evolve and deliver evolutionary and revolutionary technologies is going to be a very interesting space to watch. In other words, what is the appropriate strategy for densifying a building that's sort of in between that zone? And are there technologies that are available today? Can these technologies be deployed in work in concert and harmony? Are there interference issues? Handoffs? How does that really work? And I think that's a very interesting space for us to continue to watch. So in the evolutionary strategies and technologies, let's talk a little bit about sort of the state of the industry. And I think if you'll recall a couple years ago when we were talking about small cells, the assumption was that small cells were going to be first deployed at a wide-scale basis outdoors. And what we've observed over the last year or so is it's actually quite the opposite, is that there's a faster deployment, adoption of small cells indoors. And it's really the low-hanging fruit, right? There is a known and understood business model for deploying these things indoors because building owners, venue owners have been deploying DAS now for years. There's some other advantages to deploying small cells indoors in that there's no need for permits. You've got backhaul, you've already got a pipe into the building. And of course, as we look into the future, the near future, the wireless operators have to be deploying LTE. And so you've got a lot of the business cases and rationale for deploying indoors. In contrast, outdoors has become problematic. And we observe that deploying small cells outdoors is difficult because there is a lack of a repeatable process that's for site acquisition, for backhaul, for maintenance. I mean, think about it. I think one of the presentations earlier commented on, if you have fiber over here, and this is over on this wall happens to be the optimal place for the small cell, how's that going to work? And it's particularly difficult, we think, in the outdoor environment. And so you've got pedestrians, you've got how do you bring in trucks, where you deploy, where's your backhaul? And really, I think the hang-up for outdoor is really the ability to create that repeatable process. I think we look at the small cell space, and you know, like most manufacturers in the space, we're intrigued by small cells. We're exploring small cells as part of our toolkit. So we don't see small cells as an enemy. We see that as a piece, as a tool in the kit. But clearly, small cells, there are certain challenges that small cells have. And you look at the DAS industry, and while small cells come at a more attractive price point, there's the dilemma of neutral host. Can you provide and support multiple services on that infrastructure, or are you going to wind up with a building whose ceiling looks like Swiss cheese? So let me flip over a little bit to on the DAS side. And one of the key trends and observations in this evolutionary track is DAS is getting smarter. You know, we're talking about the industry is moving from today's DAS to a digital DAS that brings things that make it easier for the industry to design, build, join, optimize, monitor, and manage the network. It also provides a digital DAS platform, the ability to have fiber adaptability that's going to be able to support multiple standards and technologies, including DAS as we know it today, Ethernet, and CPRI, and that can be deployed for both indoors and outdoor applications. And then I think most interestingly, and we're looking at a number of venues who tend to be really focused on green, on power conservancy, and really maximizing asset efficiencies and making it simpler to do that. And then lastly, I would observe that there's an outdoor DAS renaissance coming. The fact is that macro network is not going to be, it's not the effective way, whether it's rural, whether it's in high dense urban environments, that we're going to need ODAS. And ODAS to us can be, you know, the big iron approach of 40-watt solutions, but it can also be smaller 20-watt solutions that are almost like a light bulb in the ability to provide light exactly where you need it to fill those capacity holes. So that's what we see what's coming on the evolutionary side. But there's also some revolutionary technologies coming. And we talked a little bit a moment ago about Cloud RAN. I think there's some Cloud RAN sessions on the schedule. But Cloud RAN, in our opinion, is one of those things that we're going to take some time to figure out how to define it. But Cloud RAN is really about scalability. And we think that it's actually quite a paradigm shift for the industry, in that when you deploy Cloud RAN, you're not deploying it for an immediate ROI. I think Cloud RAN is actually a setup. And what I mean by that is that Cloud RAN sets up the ability in the future to deploy more stuff to adapt and react and respond to technologies and market capacity requirements, so that you're able to go to market faster and you're able to create an accelerated path for revenue. And then lastly, another component that I would highlight in this revolutionary side of things is the enterprise network. The enterprise is going to be based upon a passive optical LAN, one that the industry is ultimately seeking a single infrastructure, an infrastructure that stays in place, and then you can add stuff to it. You can swap out the front end and the back end of it in order to scale, and that we need to be able to do more. In other words, we need to break out of this sort of infinite capacity and coverage loop discussion and into one where there are true business models. The ability to do more than just cellular coverage or public safety coverage or Wi-Fi access points, but one where you can have a single infrastructure to do more, to monitor, to do security cameras, to do temperature monitoring, asset monitoring. If you flip that on the outdoors, I would observe that you could, well, let's stay indoors. These sort of networks can also support beacons for advertising. They're large venues, they're malls, they're casinos. You can do that, and that is going to be, in our opinion, one of those revolutionary changes in the industry going forward in order to densify the network. So I think, Jen, we're probably up at that time. In order to keep us on track, let me forego questions. Be happy to catch up with you during the next break. But thank you so much for your attention.